Welcome to the class of Design and Analysis of Algorithms. Now we'll see the concept of optimal binary search trees, that is OBST. Here we can solve this one by using the method of dynamic programming. So we'll see what is this OBST and how we can solve it with an example. So if you see the problem description, so you are given a set of identifiers, that is A1, A2 up to AN, such that A1 is less than, A2 is less than. That means it is following some order. It may be like if I take A1, A2, A3 are some words, so it might follow some dictionary order. So like this. Let P of I the probability of successful search and Q of I be the probability of unsuccessful search. That means when you are searching a word in the dictionary, how you can check it out. Let me take some example, like if I want to search for optimal. So first of all, you see where is O, and afterwards after getting the words in O, you will check O, where is OP. So like this, what is that effective way? So how easily we can get the answer? And also if you Google it in Google search also, you can get some suggestions when you type the characters one by one. When you type O, it will give all the search suggestions. So some searching algorithm is working in the background. That means the words are ranked. So here also we will see how effectively we can make that as tree-like structure, where of course we know the tree is the best one, very effective way to search a node. So like this, here we will see nodes as words and how effectively we can arrange the given nodes, or here we can take it as identifiers. So we will see that one. So for that we have the values like probabilities P of I, where the probabilities of successful search of each word, and Q of I be the probabilities of unsuccessful. When I say unsuccessful means which may have one extra compared with P of I. Why? Because here 1 to n, but here 0 to n. So here we are including unsuccessful search also. So we are finding this tree with minimum cost. How to find that tree? So first of all, we have to know what is a tree, which consists nodes and branches. And of course we know what is binary tree. What is binary tree means? Where you can have at most 2 children for every node, not more than that. And what is binary search tree? So it is those nodes will be arranged in a manner like in an order. Let us suppose if I take the numbers in the left subtree, if you take any subtree of a tree, all the left subtree nodes are less than and all the right are greater than, or else vice versa. So it has to follow some order. If you take alphabets, so all the left subtree nodes should be less in the alphabetical order and all the right should be in the greater or in reverse. So but has to follow some order. So coming to what is this optimal binary search tree. So we'll optimize that binary search tree. So we'll see by taking an example. So I'll take first an example here. So I have given 4 number of words, do if int while, that is A1, A2, A3, A4. Probability of successful search from 1 to 4. That's why because 4 words are there, and for unsuccessful it is 0 to 4. That's why 5 values. So if I say probability means you can feel that the values between 0 and 1. But why we have these values? That means these are normalized. Like let us take this value is 1, this value is 1, this is 1 by 3, this is 1 by 3. If I multiply all with 3, so now I'll get like this. So these are just normalized. For this, if you take the what is the common part, that is 6, you need to divide. If you divide with 6, you will get the values actual probabilities. So that's why if you multiply those probabilities, you will get these values. So this is some normalized manner. So like this we can remember. And we need to find these values. What is W00, C00, R0, like this for all those things. Here you have 4 words, that's why up to 04. Anyway, we'll see this one also. First we'll see what is this. So what is a tree? What is a OBST? Which is Tij, which is a tree. Tij denotes, I means the node that is from AI plus 1 to Aj. Let us suppose if I say T04 means it starts from A 0 plus 1 1 up to A4. So that is only I have taken that example. So that's why up to 04 I am finding the tree, where the tree consists 3 types of values, W, C and R. So we'll see what is this W, C and R. Cij denotes the cost of the tree and wij the weight. Cost will be there and weight will be there. You need to find those things. And T0n. What is T0n means? Final tree. Anyway, final tree. T0, how many nodes are there? The values. So T00, that means empty. So there is no node. Ti, I plus 1 means only single node you have, which is adjacent values. That's why only one element you will have, that is only ai plus 1. So during the computation, the root values are complete. Rij will be calculated. Anyway, we'll discuss those things. So first we have to find these values, that is Cij, Wij and Rij for each one. After finding, you need to construct the tree. So first I'll go for this one. Of course, somewhat lengthy process. Okay, I'll explain clearly by line. For each sort of the thing I'll explain. I derive one by one. And remember this point. This is a dynamic programming concept. That's why you need to do this concept, these problems carefully, because whatever the answer here you are getting, maybe you can use in this row. And whatever the answers you are getting in this row may be used here. So the answers you can use here. That's why if you get mistakes here, it will be reflected here. Again it will be reflected here. Like this you will get all the things are wrong. So be careful when you do these sort of the concepts. So now I'll find these things W00, C00, R00, like this. For each one I need to find. Now first I'll go to the formulae. So these are the formulae, those are given. Applying the following formula. If I is equals to j, I need to apply this one. If j equals to I plus 1, I need to apply this one. That means I equals j, when I equals to j. So if I take this one, the first value is I, second value is j. So I can keep like this here. Let us suppose this is I, this is j minus I.